All right, in this video, we are going to talk about the side angle side procedure using the law of cosines in the side angle side case. So what you want to do is to use the law of cosines to solve for the side opposite the given angle. Now you're going to know what some angle of the triangle is, right? So find the side opposite of that triangle. Next, right, you're going to use the law of cosines to solve for one of the unknown angles. So you can pick either angle of the other unknown angles and solve using the law of cosines, or you can use the law of sines. And now if you go this route, you have to be careful. It's way better to solve for the angle opposite the smallest side, okay? And why is it important to pick the smallest side? Well, in the smallest side, the angle opposite the smallest side has to be an acute angle, less than 90 degrees, okay? And so when you go to solve for that angle, your calculator is going to give you the measure of that angle. And if we're going to use the inverse sine key on your calculator to do that. And so since it's in quadrant 1, remember, inverse sine always gives an answer between negative pi over 2 to pi over 2. And so, if, or 0 to 90, if you want to think about it that way, or from minus 90 to 90. And so that is always, your calculator, the inverse sine key, is always going to give you that quadrant 1 angle if you use this angle opposite the smallest side, okay? If you don't do that, then you run the risk of your calculator not giving you the correct answer, and then you'd have to make some adjustments there. So it's better just to avoid that issue. It's kind of like the ambiguous case, right, of the law of sines, side angle, where you had to look for two cases. So if you go for the angle opposite the smallest side in the law of sines, that will avoid that ambiguity there. And then finally, once you've, after that point, you'll know two of the angles. To find the measure of the third angle, you just subtract the measures of the ones you know from 180 to get that third one. All right, so let's take a look at an example. In this example, I am just going to use the law of cosines twice here. Okay. So first, in this problem, you can see I'm just given some measurements. I'm given that angle B is 30 degrees, angle A, or side A is 10, and side C is 12. All right, so I'm going to draw the triangle out. I'm going to label the angles. And the one I know is B, that's 30 degrees. So that's up here. And then I know that A is 10, so that would be over here. Right, opposite angle A. And I know side C is 12. All right. And so there I've labeled everything correctly, set up the triangle correctly. And if you look back at our procedure, right, the first step is to solve for the side opposite the given angle. So the given angle is B, so we're going to be solving for B here first, all right? And so we are going to, looking back at these formulas here, we're going to solve for B, right? So we're going to use this middle formula right here, okay? All right, so B squared equals A squared plus C squared minus 2AC times the cosine of angle B. All right, so that's what we've got, and then you would put these numbers in here. A is 10, C is 12, A is 10. C is 12. And times cosine of 30 degrees. All right, and you can simplify that down. It's 100 plus 144 minus 10 times 12 is 120, and 120 times 2 is 240. All right, and I can simplify it a little more by combining these two numbers. 244, 100 plus 144 is 244 minus 240 times the cosine of 30 degrees. All right, in this case, 30 degrees is one of the special angles, so we know that its cosine is square root 3 over 2. But, you know, at that point, you'd have to basically go to the calculator anyway to figure out what the square root of 3 is. And then we also have to take the square root of this as well. But I just want to point out something. Some people, when they're working through this, right, they want to combine these two numbers first, and you can't do that, right, because this 240 is being multiplied times the cosine of 30. So if you remember back to the order of operations, you have to do the multiplication first. All right, so we multiply these first and then subtract that value from 244. So don't, you know, combine these numbers there. Like I said, we know the cosine of 30 degrees is square root 3 over 2. So, but in most of these problems, you're not going to know. It's not going to be a special angle, and so you're not going to know what this value is. So I'm just going to act like I don't know what it is. All right, and then the next thing I'm going to do is to solve for b. So I'm going to take the square root of both sides. Remember, if you're solving an equation like this, there is a positive solution and a negative solution, but here we are talking about the length of the side of a triangle. So on these problems, we are always going to go with the positive solution. All right, and so now we would go to the calculator. I'm just going to use Desmos. And it's the square root of 244. And I need to make sure that we are in degree mode. 244 minus 240 cosine 30. And I get that B is approximately 6.01. Let's just go 3 decimal places here. 6.013. Okay. All right, so I found B. Okay. And I know what that is. All right. And so looking back at our procedure, right, the next thing that we want to do is one of two things. We want to either use the law of cosines to solve for the one of the unknown angles, or use the law of sines to solve for the angle opposite the smallest side. Okay. So I'm just going to go ahead and use the law of cosines, right? If you use the law of cosines in this step, you don't have to really worry about whether it's the smallest or not. So that's what I'm going to do. And also this video just kind of gives you another example of how to use the law of cosines to solve for an angle. All right. All right. So I'm going to pick one of these. And so I'm going to pick A. I'm going to solve for the angle A. All right. And so looking back at our law of cosines, we can see that only one of these formulas involves the angle A. That's this first one right here. So that's the one I'm going to use. right, and all right, so first thing I'm going to do is to solve this for cosine of A. In order to do that, what I'm going to do is subtract b squared and c squared from both sides. So on the left-hand side, I'll get a squared minus b squared minus c squared equals minus 2bc cosine A, like so. And then in the next step to get cosine A by itself is to divide both sides of this equation by minus 2bc. Okay, so that's going to give us cosine A is a squared minus b squared minus c squared over minus 2bc. Okay, that's equal to cosine A. And then so angle A, to figure that out, I would take the inverse cosine of both sides. Okay, and so like so. Okay, and so I know all of those values. I know that A is 10. I know that B is 12. I know that, let's see, B is 6.013 squared minus c squared, that's going to be 12 squared. Okay, and all of that is over minus 2 times b times c, which is 12. All right, and so on this one, it's probably better just to go straight to the calculator and do it that way. So, oops. So I'd use inverse cosine, and then on the top I'd have 10 squared, 10 squared minus 6.013 squared minus 12 squared. And all of that divided by negative 2 times 6.013 times 12, like so. Okay, and so you can see here I get that it is 56.26 degrees roughly. Let's see, where can I write that? So A is approximately 56.26 degrees. Okay. All right, and so the only thing that leaves us to find is angle C, right? And so angle C is going to be 180 degrees minus 30, which is angle B, and then subtract angle A out of there, and we get that. That angle C is approximately 93.74 degrees. There. All right, and that is it. We have found the measures of all the sides and all the angles, so we solved the triangle. One thing about that some people have issues with is plugging this into your calculator. Every calculator is different. And so you have to be a little bit careful about how you enter this in, depending on what calculator you have. If you have questions about that, let me know. I don't have access to every version of a calculator, but I might be able to get one that's similar to yours if you're having problems putting this into your calculator. All right, that's it for this one.